Hello, today we're going to look at modelling current and voltage in a circuit. Nobody's seen an electron or an atom, so it's very difficult to get your head around some of these terms. What we're going to do today is we're going to make a model that represents what happens in an electrical circuit. I hope this helps you. This is the circuit that we're going to be modelling, but any circuit that you could build in the class could be used for this model. So we have 2 cells, 3 lamps and a switch. I've also set that up using the FET model here. There's my switch, 2 cells, 3 lamps. When I close the switch, the electrons will flow around the circuit. So what I'm going to do is I'm going to model what's happening here. So if you can write this into your jotters and fill it in as you go along, and it'd be great if you can do your own diagram of your model. On this side of the table, we're going to have what my model represents. And on this side, it's what's the electrical equivalent. So we're going to start with our first model. So very simple. All we've got here is a road and a bridge. The road, I'm hoping you'll realise, represents the wires of your circuit. And the bridge up here represents the switch. And there's water under the bridge. Normally I put mostly harmless under there. So the road is the wires and the bridge is the switch. Now, there'd be no reason to have any vehicles on the road if you just had a bridge and a circuit like this. This is a town called Circuit. So what we're going to do is we're going to put something very special in this town, because this town has a Mars bar factory. Mars bar is very important because Mars bars give you energy. So here we've got a factory producing energy in the form of Mars bars. What do you think the Mars bars would represent? Mars bars represent energy. The Mars bar factory represents the power supply. It's the reason for vehicles to be on the road. I don't get my Mars bars from the factory. I get my Mars bars from shops. So what delivers the Mars bars from the Mars bar factory to the shops? Well, it's lorries. So we're going to have some lorries. We're going to have some shops. But there's something special about our road here as well, in that our roads around a town called Circuit only allow vehicles in one direction. The vehicles on the road can only travel around the roads in Circuit around this way. So we're going to put some stores in our model. And remember, our circuit at the beginning had 3 lamps. And to represent the lamps, I'm going to use 3 shops that sell Mars bars. I'm going to pick 3 local stores, and we've got mostly harmless now coming under the bridge. So our model's building up nicely. We've got the bridge that represents the switch. We've got the 3 lamps represented by the shops. We've got the Mars bar factory representing the power supplies, and the roads only allow the vehicles in one way. So if we go and fill in our table, what we haven't looked at yet, and it's here I've marked it, is what is it that carries the Mars bars to the shops? I'm sure you all know that that's lorries. And here I've got my lorries. And my lorries here represent the electrons. So these electrons will move around the circuit. They'll make a delivery to Aldi. They'll make a delivery to Tesco. They'll go over the bridge. They'll take a delivery to Sandu stores. They'll go back to the factory, get filled up with more Mars bars, and away they'll go again. Now there's lorries all the way around the circuit. They don't all start from the Mars bar factory, but they all head towards the Mars bar factory to get filled up with energy. If we go back to our simulation, here we've got electrons moving around the circuit. Here's one shop, here's another shop, here's the bridge, and here's Sandu stores. So we've got the idea of what's happening in an electrical circuit, but I want to think about some of the measurements we've made. We've used meters to measure the current and the voltage and the resistance. We are going to model measuring current and measuring voltage. And we're going to use the counters at the side of the road. When I was at school, we had to do a survey. We all stood at the road at one time and we had to count how many cars went past us. So here, these represent my counters. They could be you or people standing at the side of the road, taking measurements of how many lorries go past them in the whole period that they're standing there. And that would be like measuring our current or measuring using an ammeter. So my question to you is, which counter is going to count the most lorries that go past them in a certain time? Another thing to notice is that I've changed the name of my town, because when it got built up like this and we built the factory and the 3 stores, we called it a series circuit. Why did we call it a town called series circuit? Because if you look, there is only one path. If I click on this lorry, there is only one route for these lorries to take. The lorries cannot have a choice about the route that they take. They have to go one path. One path is a series circuit. And what I'm going to do is I'm going to draw around this. Each time I draw a pencil line, that's representing one lorry moving around the circuit, or one electron, or one group of electrons. In reality, there are millions and millions of these electrons moving around a circuit. So we're going to call this counter 1, counter 2, counter 3, counter 4, counter 5. I want you to think about which counter is going to count the most electrons. And away we go. Okay, so just count the lines that go past. Ooh, whoops, sorry, I'm not very good with the pen. Oops, over the bridge this time, whoops. Oh dear, these lorry drivers, I think they need to come to our road safety talks. I've lost count. Okay, we'll stop there. So what we need to do is at this point, we need to count how many lines there are, because each line represented a lorry. So let's have a look. 1, 2, 3, 4, 5. Let's check. 1, 2, 3, 4, 5. So this counter, this ammeter, measured 5. 1, 2, 3, 4, 5. Definitely went off the track there. They got 5. Here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what you found is in a series circuit, the current, which represents a group of lorries in a certain time, is all the same anywhere in the circuit. And we can show that. This is our circuit again. We've seen that when you close the switch, then the electrons move around the circuit, lighting the bulbs. If we go to our model, we've got the lorries moving around the circuit, delivering Mars bars, which give you energy, to the shops, which you can sell to change your energy. And then those lorries deliver to each of the shops. Some people would say, well, doesn't the first lorry deliver to the first shop and the second lorry deliver? No, every lorry delivers to every shop, because if you were owner of Sandu stores and you saw a lorry driving past with the Mars bars on and you were a bit annoyed because he went right past your front door, so you'd expect a delivery, even if it's a smaller delivery. And we've measured that and set that up. If we look at this, here I've set 5 ammeters around a circuit, and we're going to see what the current would be. And remember that you'll get no current when the switch is open. And from our model, you should know that when I close the switch, the current should, let's have a look. Well, each ammeter has a current of 0.60 amps. And that's exactly what we found in our model. So it looks like it's a pretty good model and explained it clearly. So just to show you that our model does work, this is me. I've added meters. You can't see this one very clearly, and you can see that the current is the same. See, current is all exactly the same, 0.100. Notice the light bulbs aren't all the same brightness, and that doesn't matter. I said I'd come back to the reason why we represented the bridge as a switch with water underneath it. And there's a real problem with our circuit. Let's have a look at this video, and you might find out why. Whoops. Bridge is going to have to be looked at by the health and safety to make sure the bridge is safe. If we went back to our model and we had a look and the water level rose and either flooded the bridge or somebody in a canal boat came and crashed into the bridge, then our circuit is not going to be operational because there's no route for the current, the lorries, the electrons to take. Let's have a look. So here we go again. There's a canal boat that's rammed into the bridge. So if this bridge is taken out, can any of the lorries get past? Well, they can get as far as here. They could get over here, but they can't go round. Now, all these lorries will have sat-nav on them. And they will know that the bridge is out. That's the route stopped for the lorries. So that's not the best circuit. Now, in the next part of this video, we're going to look at voltage. And voltage is possibly one of the most difficult things to think about. We can think about it in two ways in our model. Remember that there were no lorries on the road until we put the factory in there, because nobody needed to be on the road. Once we put the Mars bar factory there, suddenly we needed a way to get the Mars bars from the factory to the shops, which is why we've got some lorries. Another way you can think of as voltage is you can think about it as the number of boxes of Mars bars on each lorry. So boxes of Mars bars on a lorry equals the voltage. So boxes of Mars bars per lorry, which is equal to energy over the number of lorries, which is almost equivalent to our electrons, or our current, or our charge, is equal to the voltage. So it's Mars bars per lorry, and a lorry represents a big chunk of charge or lorries. What I want you to think about. So we're going to put Mars bar factory. We're going to put a manager in here, and she's in charge of deciding how many Mars bars go on every lorry. Obviously, the same number of Mars bars go on every lorry. And she has made a decree that there are to be 15 Mars bars on every lorry. This lorry's just gone through the factory. How many Mars bars will it have? 15. This lorry's just been round and done its deliveries, and it's coming back to the factory. How many Mars bars must it have on board? Must have none. This lorry driver comes back with Mars bars on board. It's not going to be very long with the company. Now, can you stand at the side of the road and count the number of Mars bars on the lorry? No, you can't. And that's the same with voltage. With voltage, you can't put a meter in the circuit and expect to count the voltage across it. What you've got to do is you've got to sample. And that's like, if any of you have seen one of the weigh bridges, and the police sometimes make blockades along the motorway, and they call some of the lorries, they pull some of them off, and they weigh them, and they check what's inside. And that's what's happening here. And that's why a voltmeter, when you connect the voltmeter up, you put it across the component. Because what we're going to do is we're going to sample some lorries. We might take this one off, so all the others go through. We might sample this one and have a look. How many Mars bars it's got here, how many it was going to deliver here, and how many it's got there. And that would be the difference in potential, or the potential difference. So the difference in Mars bars per lorry from one side of a component to the other. And that's what you're doing with a voltmeter. So let's have a look. Here's a Mars bars, 15 in this lorry here. Now, it drives along here, and it gets to here. How many Mars bars should it have? Well, it should still have 15, because it's not made a delivery. Now, Audi's a big shop and sells quite a lot of Mars bars. I think each lorry is likely to deliver about 8 boxes of Mars bars. So here, it's going to have 7 boxes of Mars bars left. If we count how many boxes this side, how many it delivered to Aldi, 7 here and 15 here, so it's delivered 8 to Aldi. Now, a lorry goes along here. How many's it got here? Well, it's still got 7. No deliveries along here. Tesco's quite a big shop, so I think after Tesco, it's going to have 1 left. So how many did it deliver to Tesco? Well, it had 7 here. It had 1 here. So it's delivered 6 to Tesco. The lorry goes over the bridge. No loss in Mars bars there. And it's got 1 here. Okay, and we've said that it must have none when it gets back to this point. It also must have 0. Before Sandu stores and after Sandu stores, how many is it delivered? It's delivered 1 box of Mars bars. Now that's each lorry. What's special about this? Well, this Mars bar manager said it wanted to add 15 boxes of Mars bars to every lorry. And if we look here, we've got 8 boxes delivered to Aldi's. We've got 6 boxes delivered to Tesco. And we've got 1 box delivered to Sandu stores. And what does that add up to? That adds up to 15 boxes of Mars bars. What do you notice about that? Well, that's exactly the number of Mars bars per lorry that every lorry got. So if we relate that to voltage, the energy gets given to the charges as they go through the cell, and then they lose some of that energy each time they go through a component. They don't have to lose them equally, only if the brightness of the bulbs or the components are the same. But here we've met 3 stores and they're all very different in size. Aldi would get most, so that would be a bigger potential difference, and then Tesco the next, and Sandu the smallest. Now I've set that up on the FET, so let's have a look here again. So here's our model again. Made up in FET, and you can have a play with this later. I've left 1 ammeter in. and I've taken the rest out. Notice the bridge is open, the switch is open, there's no current, there's no electrons flowing in this circuit, but the lamps are still there. Now the question is, if I put my voltmeter across the cells, would I get a reading? Well, think about the factory. Would there be Mars bars in the factory? Yes, there would. So in this factory, we've got 18 volts across the cells. What about if I put this across the lamp? So that's not getting any energy, as we'd expect. But if I close the switch and do the same thing, naughty, naughty, put my connections around the wrong way, that bulb is got a voltage of 6 volts across it. Let's just check out the cells. That's still saying 18 volts. Okay, let's have a look at this bulb. Sorry that it's gone off the screen, but the connections are there, I promise. 6 volts there. So 6 volts across one lamp, 6 volts across the other. What should this be? This also should be 6 volts. It's like each shop is the same size shop, not like our little Sandu store compared to Audi. We got voltage of 6 volts across here, 6 volts across here, and 6 volts across here. 6 plus 6 plus 6, 18. 18 volts from the power supply. It looks as if our model works. Just to show you that this works on our model, voltmeter on the right is across the component, so that's across the Mars bar factory. Then the one at the bottom is more like Sandu stores, so that has a voltage of 0.469 volts. The one on the left has a voltage of 0.586 volts. And the one at the top has a voltage of 1.779 volts. So add up those three and see how close you get to the supply voltage. Did you manage to fill in the whole model? Does the model make sense? Do you understand that if you use our model and think about what each thing in our model represents, it can help you understand what's happening with our electrical circuits? We're counting cars with ammeters, and you could put those in series. And we found that in a series circuit, all the counters counted the same number of lorries, and that shows that in a series circuit, the current stays the same. We said that the number of boxes of Mars bars per lorry equaled our voltage, because voltage is the energy per unit charge, per lump of charge. We said that the weighbridge was like a voltmeter, and you couldn't just stand at the side of the road and count what was on the lorry. They had to go in parallel, and we found out that the number of boxes of Mars bars per lorry delivered to each shop adds up to the number of Mars bars provided by the factory, which said that in a series circuit, the voltage across each lamp adds up to the total. And we know that we had the same number of Mars bars at the beginning as we did at the end, so the energy in the circuit is conserved. In our next episode, we're going to look at an improved circuit.